Hello everyone, so now we are going to do one lab about the OSPF. If you remember, in our previous class we discussed how we can do the summarization. So in our previous class we done the OSPF summarization at ABR, Area Border Router. Because we need to remember, we cannot do the summarization anywhere in the OSPF. We can do summarization only two places, one is ASBR or ABR. So in our previous class we already discussed how we can do the summarization at ABR. Now we are going to do ASBR, Autonomous System Boundary Router, Area Border Router. Already we covered that one. So now we need to look ABR. ABR means, if you remember, we discussed before, a router which is connecting different routing protocol. If this is in the different routing protocol and this is in the OSPF, this router, we can say this router is making the communication between different routing protocol to OSPF. So that router name is ASBR. So this is we know already. So now we need to make that one here. So you can run here the OSPF. Here we have the OSPF. So here we can run the RIP or any routing protocol and we can do the redistribution. But we have one more method, simple method. What we can say, whatever is connected to me, do the redistribution. So when we do the redistribution, it will appear like it is coming from the different routing protocol, and this guy will become as a ASBR. So now we will do that one. So you will have the idea. We will take the same topology. Let me power on the devices here and let's see here. I will take the notepad so we can prepare the basic thing. Okay, what we are doing, summarization, root summarization. We are getting a lot of roots from R1 to R2, so we need to filter. So we will have the summarized root. Already we know how to calculate the summarized root, everything we know that one. We done in our previous class about the ABR. We implement that one at ABR. Now we are going to do ASBR. So let's do here the basic configuration. Before that one, let me write here in the notepad. We will say like OSPF Summarization at ASBR. I will write here R1 configuration enable config t host name. I will give R1. Then we have the interface loopback 0. First of all, let me write here no, so it will boot up and it will be ready. Here also I will write no, so it will boot up. Okay, this is okay. So now first I will define the loopback. Before loopback, let me assign the IP to one interface F0 by 0. I will write here IP address, whatever IP address we are planning to use here, 192.168.12.1, 255.255.255.0, and then we will write no shut. Then we are going to use the loopback interface loopback 0 IP address. We have 172.16.1.1, give space 255.255.255.0, and then we will write interface loopback 1, then IP address 172.16.2.1, 255.255.255.0, and then we will write interface loopback 2 and IP address we will write here 172.16.3.1, 255.255.255.0. so this one we have till 3. If you want, I will add one more. I will give loopback 3 and I will write here IP address 172.16.4.1, 255.255.255.0, and I will write here this one. Okay, so what I done, just I assign the IP address to the R1, and now we need to enable the OSPF. So I will write here router OSPF 1 interface. Which interface I will enable? This fast Ethernet 0 by 0. So I will write fast Ethernet 0 by 0 IP OSPF 1 area 0. We are using area 0. So I enable only one interface OSPF. Remaining interface I did not enable because I want to do a what we can say redistribution. So I enable OSPF here. Here I will not going to enable. I am going to do redistribution connected. So whatever interface is connected, it will come into OSPF as a external route. Then this router become as a what we can say ASBR. So we will do that one. How I can do? We will use this command. I will write here router OSPF1, then redistribute connected subnet. Okay, with this command we will do. So when we put this command here in this router, all this connected interface will go in the OSPF. So let's do. I will copy paste. Let's see. I will go in the R1 and we are going to paste this in the R1. So everything is good here. I have some spelling mistake here, I think. So let's do here redistribute connected subnets. Okay. So this one I have error, so I will copy, I will modify here. So now we need to do the R2 configuration. This is the R1 configuration, whatever we discussed. Now we need to do R2. So here for R2, let me copy this some stuff here and we are going to modify as per our requirement. So this is the R2, here also R2. What we will do here, I will say fast Ethernet 0x0 12.2. This should be 12.2. Okay, this is the R2 we can say. And if you have any loopback, do loopback, but we don't have any loopback. So now we can do the OSPF configuration for this one only. So I will write here router OSPF1 interface fast Ethernet 0x0 IP OSPF1 area 0. Okay, I hope it is clear for you. Just I enable the OSPF under this interface fast Ethernet 0x0. So let me copy and paste this and we will verify. So I will go here, this is the R2 and we are going to paste this in the R2. So now everything is good, we can verify. So if you wait for some time and when you check here show IP route, you are going to get the more routes here, but still you are not having the more routes. After some time you will get. Okay, because this network, if you see this one, you are learning this route now. E2 you are getting. E2 is nothing but you can remember this one as a external. If you see where is E2, this is a E1. Okay, so here is E2. E2, if you are receiving 0, that is OE2. That is what is the meaning of OE2? It is nothing but OSPF external type 2. So this is the routes we are receiving externally. That is not from the OSPF any other routing protocol. We learn this one and someone do the redistribution, so this came inside the OSPF. And this is a E2. E2 is nothing but they are going to put the cost as 20 by default for all the routes. If you need the original one, you need to convert to E1. So E1 is a OSPF external type 1 we are calling. E2 is a OSPF external type 2. So just you need to remember the cost will remains 20 if we get the E2. By default, when we do the any external route redistribution into the OSPF, we are going to get as a OE2 and the cost will remains 20. So this is the remain cost 20. If you want to get the actual cost, you need to convert this into E1, then you will get the actual cost. But anyhow, no problem, we will keep here. So what you are learning here, these 4 routes are coming to R2. Okay, these 4 routes are coming to R2 with the E2. OE2 means external route. This is the external route coming to the OSPF. So this is a router which is R1 who is behaving as a what we can say ASBR. If I write here, if you see show IP OSPF, you can see somewhere here it will be written as a, let me see where we have, it is O routing ASBR, you will see that one. Let me check here where we have show IP protocol, or if I write okay, I think with this command show IP protocol here, yeah, if you see this one, it is an autonomous system boundary router. Okay, ASBR, it is an autonomous system boundary router. If you remember in our theory we told a router which is connecting different routing protocol to OSPF, that router is known as autonomous system boundary router. ASBR we are calling. So this router is a ASBR. If you see, this is a router which is a ASBR which is connecting the different routing protocol to the OSPF. Okay, so we can say that is a OSPF. We are using the OSPF. but other side we are not using OSPF, we are using this one as a directly connected. So I done here directly connected redistribution. If you want, you can run the RIP here. From RIP we can put that route in the OSPF, but anyhow both are same only. We can use this for lab purpose. Okay, for the lab purpose we can do this, no issue. For lab purpose we will do this one. And what else we can say now? Now we can do the summarization. So first thing, what we told, this is a router which is behaving as a ASBR. If you see ASBR, and here you are learning the routes. So if you see, or I can do another way, show IP route OSPF. So you can see this is a route. Imagine you have 4000 routes. Now we have only 4 routes. But imagine if you are getting the 4000 route, then how we can fix this one, how we can look. Okay, how we can fix, how we can look, because our database, the routing table will be full if you have 4000 routes. So to avoid these types of issue, what we will do as a summarization. Okay, route summarization we will do. So how we will do? Same procedure as we do before. So first of all we need to calculate the summarize route. So in the R1, what I will do here, I will calculate the summarize route. If you remember, before we told we can do from the internet or we can do manually also. So let's do manually. I will write here calculating the, if you want, if you have the calculator you can use calculator also, but here I will do manual summarize route. So first one I will write the first IP, whatever we have we are using. So first one we are using this one, and last one we are using, I think last one we are using this one. Okay, so these two we are using. So what we will do, if you see this one and this one both are same, this one are same, so only the here and here is difference. So in that scenario we will put this complete IP, and where is the difference, you will convert this into binary. So 8-bit we have, so here is 4-bit, and again you have the 4-bit, at last you will put 1. So this is a binary 1. We can convert this decimal into binary 1. Okay, 4 here and 4 bits here. So now I will take the last IP also. For here also I will do same thing, this 0. If you see, first above and below is same, here 4 we need to convert as a binary. So 4-bit will remain same here, then space, then 0 1 0 0. If you don't know, you can use the calculator also to convert the decimal into binary. So if you see, this is converted into binary, this portion here and here. Now we need to check what is the value is common. If you see here, this is 172 8-bit, this is 172, that is 16 8-bit, and here how many bits are same? Till here it is same, and after that it is different. So 1 2 3 4 5 bits. So if I write here, if I want to calculate the subnet mask, I can write this way. First of all, what is the IP? We will say 172.16.0.0. This way we can define the IP. Okay, after summarization, this way we can say this is a IP. This both are same, this both are same, and here 0, and before we have 0, so we will keep. This is the summarize IP. Now subnet mask, how we can calculate this one? How many bits? 8 bits. So we will write here 8. Okay, and for this one both are same, wherever both are same you will put that bit. So here is also 8, and here how many same? This one. Here is different. If you see, this one and this one is different. Above is 0, below is 1. So till here is same. So if you count this 1 2 3 4 5, so total 5. So you will add here this one. So how much you will get? 8 plus 8 plus 5, so 21. So that is nothing but we can say this IP /21. So what is the meaning of /21? If you want to write /21 in the form of 255, you can write 255.255.248.0. okay, this is subnet mask. So you need to write this IP and this subnet mask when you want to do the summarization. This is a manual method we done. You can Google summarize calculator and put this to IP. They will give you directly this one. Okay, now how we need to put means, you need to go under the OSPF and you need to put this route. Example, you want to put, how you will do, you will write router OSPF 1, and after that you will write summary address and put here the address, whatever address you want to put. So this is the address, so I will put this address, summary address, give a space and put the subnet mask like this. Okay, only these two things you need to put in the R1, then R2 will get the summarized route R2. Okay, so let's do in the R1. I go in the R1 and I am going to paste here this one. Sorry, I did not copy. Now I copy, let's put here. After some time you can check here, you will get the summarized route instead of all this one. See here, before you are getting how many? 4. Now you have only 1, OE2 only. So this is a summarized route. So imagine if you are getting 4000 route, you can summarize, so you can save the memory, CPU and load on the router. And now you can ping also. It will not like you will get only summarized route, you can ping also, like 1.1 it is working, and you can check 2.1 it is working, and you can check here 3.1 it is working. And what you have last network, I think 4.1 also you have, so it will work. So this way you do the summarization. So here what we done here, first this router is not a normal router, this is a router which is converting the other routing protocol to OSPF. That's why we are getting OE2. And what is the name of that router? If you want to check, you can see that router is this one. It is a autonomous system boundary router. It is a autonomous system boundary router. So we can say it is a autonomous system boundary router is a router which is going to convert different routing protocol into OSPF. So this router converted and they give you this E2, this option, but you are getting lot of. Now we taken 4 only for the lab purpose, but imagine for real scenario you are having 4000, then we will do the summarization. So where we will do summarization? In R1 only. Just go under the OSPF, put this command, summary address, and whatever summary address you calculated, that one only. If you are having confusion here, calculation this one, just go to Google and write summary calculator and put the IP, first IP, last IP, or put all the IP whatever you have in the interface, these routes, they will calculate, they will do this one, and then you will put here. That's all. Okay, so this one what we can say this is a route summarization or lab OSPF summarization at ASBR. So try to practice this one. This is simple topic but important. Okay, so let me